These things are great. Perfect little shafts with a collet holder on the end. They come with a set of collets, so you can put various drill sizes in there. I bought 4. And I'm using 5mm bits because they'll match these little rivets. And I added a pulley. And I put them into bearings and mounted the bearings on a sled. Which fits oh so snugly into a jig. Which fits into the docking port on the lathe bed. Nice! But how to make them go round and round fastly? I considered using a battery drill, but that would need some sort of counterbalance because it would try to tip up the sled, wouldn't it? Because it's very heavy. So in the end, I went with a motor attached to the ceiling, sort of, and a round rubber belt, the sort that you just melt together to get the length that you want. That's an old bench grinder, so it doesn't spin very fast, which is good, I'm thinking. So now I can drill 2 holes right through the centres of the handles at the same time in the right place. Yes, it takes a minute to set up, but it means I don't need to take the handles off the lathe. I found a bit of Vaseline makes all the difference. Then I'm experimenting with these little deburring tools for making a recess for the rivet head. I could put those into collets too, but freehanding them seems to be working, at least for now. Right then, good. Now I want to show you an exciting development. Well, maybe it is. You see, I was planning to drill a second, smaller hole in each handle, as you know, for a pin that stops the lever going too far. That's why I made the drilling jig and set up the motor and everything and bought more collet shafts. I could just make a second sled with 2 more drill bits mounted on it, and I'm sure I could make that work. But I've been tweaking the drawings again and again, and you will notice with any version, and there are dozens more, there's just not a lot of room in there for a pin. It's there to stop the knife opening up too much, of course, so the lever stops against it, but I don't want the sharpened blade side to touch it. There is some space, but not much space. But now, what if I make the slots and the blade and the lever like this? That way, there's no need for a pin. Just a nub of timber left in just the right place for the lever to stop against. Now, obviously, if you put enough pressure against it, something would give. The timber would surely break away. But if the contact area is big enough, then it would be strong enough. So the question is this area here where the end of the lever meets the inside of the handle, is it strong enough to hold the blade while you're using it? If so, then I don't need that second pin, so I don't need extra holes. And I would have designed the simplest pocket knife possible, just 3 parts. Of course, there's only one way to find out. We need to test it. And for that, I need to cut these new slots in the right places and fit some sort of blade. And these are my new slot cutting jigs. They go into the docking port as well. And crucially, they are fully adjustable. That's one of the main things I've learned in this project. As you get closer to the finished size of whatever you're making, the adjustments get finer and finer. So you need to be able to make those tiny adjustments and make them permanent. So with both of these, I can adjust the limits to the lateral and longitudinal movement, or X and Y if you prefer. Now again, many people said I'm doing this all wrong. For one thing, I should be machining the slots and drilling the holes in a square block of wood. Drilling and slotting and then putting it on the lathe. And they'd be right, but only if those blanks are all the same size. So far, I'm just raiding the woodshed and the scrap shelf for my experiments, and I'm using whatever I can find. And I'm roughing out my blanks and then leaving them to dry if they need it. But none of these would be suitable for machining in the square block. They're just not uniform enough. They'd all need to be resawn or go through the thicknesser to make them identical once they're dried out. Another suggestion made by many people is for sawing the handle down the middle, milling out the inside and then putting the two halves back together again. And I know that's a very common approach, and it's a good approach if you want to add locking arms or internal plates or whatever. But all I see are many more steps in the process. Splitting and rejoining for a start, maybe another rivet or two, so more holes. Basically a longer process. Now if these knives are going to work, they'll work because they're simple and quick to make, and anything that slows them down adds to the price that I need to charge for them. I hope one day, if things work out, to be able to challenge any of you to a race, a knife making race, because I think my approach will work out faster than, the resawing and the layering and scales and gluing and riveting and all that. But we're not there yet. Perhaps we'll never get there, but we'll see. This is a mock-up of the blade. This is not the finished blade, all right? This is just mild steel cut on my marvelous plasma cutter with no heat treatment, no sharpening or polishing or anything like that. This is just something to test the design with. Making an actual blade from high carbon steel is a huge and fascinating subject, and it's something I'm really looking forward to learning about, but I'm not ready to invest in any of that stuff yet because I need to know that there's a chance of success. So I just want to put the mock-up blade in the handle and test the handle for strength. So this is all about how well that internal shape of wood stands up to normal pressure. If this was a smaller knife, then I would say the area would be too small and it would just break out. On the other hand, if it was a bigger knife, that area would be bigger, but the blade would be longer too, so the leverage would be greater. So it's an interesting experiment. What do you think will happen? Go on, will it hold or will it break? Well, I started with one of my rotten alder handles. I've been experimenting mostly with this wood because it's so easy to cut and turn, but it's literally rotting, as you can see. Spalted timber, another name for partly rotted timber, can be quite attractive, but it's never going to be strong enough for this test. And of course it broke straight away. Fair enough. I'd be surprised if it did anything else. So then I tried some ash. Ash dieback disease is killing vast numbers of these trees across the country. It's very, very sad. But it's going to be obviously one of the timbers that I would most likely be using for handles. The unaffected parts, obviously. And yes, of course I can break this if I try hard enough, if I put enough weight on it. But would it break in normal use? Normal use is a bit difficult to define, I suppose, but you know, opening bale wrap or cutting string or whittling timber or pruning roses or cutting up an apple, well, it's going to work for that, isn't it? 18 kilos plus 9 kilos plus 5 kilos is 32 kilos spread across the bar, of course, but mostly directly on that knife joint, and it's holding, which really is quite exciting because that means that I could make really simple folding knives with just 3 parts, not 5 parts or 7 parts or 27 parts, just 3 parts. Actually, I did think about it for a while, and it would be possible to make a folding knife with just 2 parts, but it wouldn't be easy or neat. So I think 3 is as simple as you can go. Right then, now I need to think seriously about the blades and the finishing. So lots more to do, but I am relieved to have got this far. Onwards, people, onwards!